Hello, in this video we are going to learn about the DC-DC converter, and we have taken just a pure example. Let us say there is a load resistance R and we apply a voltage VD, and we are not using any type of filter or any circuit freewheeling diode and just a switch. So practically this type of connection is not valid because it will lead to different harmonics, and this is not a valid that you will get out voltage where the output voltage jumps from VD to 0 and during when the switch is turned off. The time period is, the switching interval is TS, in which it is on for T on time. So we can give a name like, let us say D. D is the time interval for the switch to be on. So we can write D is equal to T on by TS, or from there we can write T on is nothing but D times of TS, and T off is nothing but 1 minus D times of TS. So let us obtain that if this red line obtain the Fourier series expression for the output voltage waveform, and see that this waveform contains what is the average voltage and what is the because we know that we can get V0t is equal to VDC plus summation of n is equal to 1 to infinity an cos n omega t plus bn sin n omega t. This is the Fourier series expression. So we are taking in terms of t here, and we can write in terms of theta also. If we write in terms of theta, there is no much difference. Only thing is that the expression of n will be same, 1 to infinity an cos n theta. The variable is now, instead of omega t, will be theta, bn sin n theta. Here, okay, let us use this space. Here PDC is nothing but 1 by 2 pi. If we're using t, so we will write the expression of VDC is 1 by t integration of 0 to t V0t dt. And if we want to know what is an is 2 by t or 1 by t by 2. 0 to t V0t cos n omega t or cos n omega t dt. And we can say that Bn is equal to 2 by t, 0 to t, V0t sin n omega t dt. Let us evaluate this value, and this thing is very simple because V0t is, we know that, we can write here that V0t is very simple, is Vd from 0 to t to dATS, and it is equal to 0 from dTs t to ts. So V0t is very simple. Let us evaluate. So we can write VDC is equal to 1 by ts. Ts is the total time. Integration from 0 to d times of ts, and because the rest of the time it is 0. Okay, let us write like this. V0t dt. So we can write like this 0 to dTs. So V0t value is Vd here dt. So this is nothing but integration is t. So we can write here Vd t limit from this is Vd by Ts, T limit from 0 to, this will lead to like this, and this to cancel out, and you get d times of Vd. So you can simply get the value of the average value, Vds is equal to d times of Vd. That is very clear. If the switch is on for 50%, output voltage is 50%, DC value is 50%. Let us evaluate AN. So when we take the value of AN, it is 2 by Ts, 0 to dt, dts, Vd is the output voltage, and cos and omega t. So this led to 2 Vd by Ts. Integration of cos and omega t will be sin n omega t. So sin n omega t, n omega will come down because we are integrating with time, and this will be cos, integration is this, and it is limit from 0 to dts. So this can be written as 2 Vd by Ts into, so this n omega will be multiplied at the bottom, it will be like this, and we can write here omega as, so n into 2 pi by Ts, or 2 pi Fs, we can write substitute the value of omega as 2 pi by Ts, and here we are writing here as putting the value of dts here, so this is sine of n omega. So omega, let us write 2 pi by Ts into, we substitute the value of dt, so dts. So this leads to, let Ts cancel out, 2 cancel out, Vd by n pi, and this side Ts cancel out, this is sine n 2 pi d. So this is the value that we are left out with, the AN value. So it means that this AN value is having a magnitude, that is A1 we can get, A2 also we get. So let us evaluate. So by substituting the value of AN, A as 1, N is as 1, so we get Vd by pi, sine of n is 1, 2 pi into d. When n is equal to 2, this is Vd by 2 pi sine of 4 pi d. Like 3, Vd by 3 pi sine of 3 2 pi, so 6 pi d. Let us get the value of Bn. So when you evaluate Bn, this is nothing but 2 by Ts, again 0 to dTs, Vd, this time this is sine n omega t dt. So what we get here again, 2 Vd by Ts, the sine integration is minus of cos n omega t by n omega. So here also this term will just omega value we can put like n into 2 pi by Ts, Ts cancel out. We can write here 2 Vd by, this 2 also get cancel out, so Vd by n pi, and here minus sign is there, so the limit is also there from 0 to dts. So since minus sign, we will interchange the limit. Now we can remove this plus minus sign from here, and we can write here dts to 0. After that we can put the limit here, cos 0 is 1 minus cos of this, cos of n omega t is d times of ts. I can write like this, and then we can write n pi 1 minus cos of, just like the top here, n 2 pi d. So we get the value of an and bn. So here we take the value, assume that this value is equal to a sine of phi. We trying to convert this into the polar form, so this is a sine of phi, and similarly this phi is equal to a cos of phi. So if we just square both the sides and add, so it will come down like this. So sine square, and here it is 1 minus b, a minus b whole square is a square plus b square minus 2ab, and that is equal to sine square phi, and cos square phi is 1, so a square. And we take the common here, sine square cos square is 1, so 1 is taken common, so 1 plus 1 is 2, so we take common from here, 2 take common 2 from here, so it is 2 outside, and what you get, 1 minus cos, let us say 2 n pi d, so 1 minus cos theta is sine square theta, so 2 sine square theta, so 2 sine square n pi d, so 2 is 4. So if we take a is equal to root over of entire thing, that is 2vd by n pi sine of n pi d. So this we get the value of a, and to get the value of phi, we can calculate that if we take the ratio between these two, so it will be 10 of phi is equal to, these two cancel out, so here sine of n 2 pi d by 1 minus cos pi 2 pi cos n 2 pi d. So this is n actually. Okay, let me just n 2 pi d. So here we can write here as 2 sine of n pi d into cos of n pi d, and this is 1 minus cos 2 is 2 sine square n pi d. So here this sine and this 2 to cancel out, so what remaining is the cot. So we can write this as 1 by or we can write here as cot of n pi d. So 10 pi is equal to this much, so pi is equals to 10 inverse of cot of n pi d. So once we get this value, we can substitute here, and we can write this equation as b0t is equal to, this is b times of vd. This expression will be, we take the a as constant, 2vd by n pi sine of n pi d whole multiplied by sine of, we can write sine, or we can write sine of phi plus this much, so it is n omega t plus phi. So where the phi value is this one, so we can write in terms of phi also. So we can write here, this is 10 inverse of cot of n pi d. So this is what we are going to write. So this is the expression. So here the expression changes with the d value. So whatever the d value, accordingly, let's put some value here. So here we are getting this expression here, vd by 2 plus summation of n is equal to 1 to infinity when d is equal to 1 by 2. In that case, we are getting this as sine of d is 1 by 2, so n pi by 2 sine of n omega t plus 10 inverse of, we can write cot as 1 by 10 n pi by 2, and we can get the expression of this. Let us say this is c1, this is what is c1, so the c1 component is this entire component for different value of n. So we get the value of n for different value, and we can write here v0t is equal to vd by 2 plus c1 value 2vd by pi into all the terms c1 and its component. So not necessarily this entire thing is c1, rather we can say coefficient as c1, and then we get the value of sine. So we get Vd by pi sine of omega t plus 2Vd by 3 pi sine of 3 omega t plus 2Vd by 5 pi sine of 5 omega t. Like that we can proceed. And if we do the Fourier spectrum analysis of this waveform, so what we're going to get is, we are going to get here the output as a VDC by 2. So we are going to get here output as a DC component. This is Vd by 2. Then we are getting the first switching frequency, because omega is here 2 pi by Ts or 2 pi Fs. So let us say my Fs is 1050 Hz. That is 21 times of 50. So the next is the 21th order. We'll get the magnitude. This is equal to 2 Vd by pi. After that it is third one. So accordingly we can write either as 21, or we can write here the 21th order. So this will be of Fs, and like Fs is the 2 Vd by pi, and this is Fs actually, switching frequency. So we can think that how switching frequency is 21 times of the fundamental frequency. So we have to write it like this, that switching frequency is 1050 Hz. So we get at switching frequency we are getting 2 Vd by pi. Then we are getting the next one as 3 times of Fs. So we get the next one as 3 times of Fs. After that we'll get 5 times of Fs. So obviously this term will be 2 Vd by 5 pi. This is 2 Vd by, this is 2 Vd by 3 pi. And this is 2 Vd by 5 pi. And like that we are going to get the other terms, 7Fs and other terms. And this is what we understood, that if we have this output voltage as here a DC, which is of duty cycle, half of the duty cycle, that D is 0.5, and it is oscillating, V0 is changing from 0 to Vd and 0, like that. So we are getting a DC value. This is the VDC we are getting. But apart from DC, we are also getting the first sine term, that is Fs, with a peak magnitude of this value, 2 Vd by pi, and 3 Fs. So if my value is 1050, so 3 times of this will, like it is very distance apart, 5 times again a distance apart, like that. So the first one, which is of more important, is 1050, and we will try that. We cannot have a switching frequency Fs as 50, we will not appreciate that. Rather, if we have a switching frequency of 5 times, also not appreciated. If it is 21 times, okay, because these are the harmonics which is not to be present in the output. We don't want these two harmonics to be present in the output, because this will cause a lot of losses when we want output. So we can summarize that in this, it has got a DC term. So the DC is a DC term, this is a DC line. It has also got a sine term. So it can have, like, it has got a like sine term, and it's a very high frequency. So we can say this frequency is 21 cycles in one cycle. So we have a sine term, another sine term is there, which is a very low, another frequency is there of very small value. So we can add up these values, very small. So these are the some harmonics are there. So these harmonics, if this frequency is of 50 Hertz, it is a problematic. Then we'll have a like cycle like this, we have a cycle like this. So this will be dangerous. So we don't want this 50 Hertz. We want a very small output voltage over here. So this thing not we don't want. We want it is to be 21 times. 21 times with 50. So this is okay. So this is how why the frequency is switching frequency is to be more than 21 times of 50 in that range. And we have to take care of Fourier series. We understood this.